All right, hello everyone. Now we're going to be doing section 4.3, which is solving systems of linear equations by elimination. So in our last section, we learned about solving systems of linear equations by substitution, and we also learned by graphing. So elimination is going to be another one of our more algebraic methods that we'll go ahead and learn. So our objectives being that we want to solve linear systems by elimination, we want to multiply when using the elimination method, we want to use an alternative method to find the second value in a solution, then we want to solve special systems by elimination. So starting with objective 1, we're going to solve linear equations by elimination. So recall that adding the same quantity to each side of an equation results in an equal sums. So we say that if A is equal to B, then A plus C is equal to B plus C. We can take this equality one step further and add equal quantities instead of the same quantity to each side of an equation to get equal sums. So now we're going to say that if A equals B and C equals D, then A plus C is going to be equal to B plus D. The elimination method uses the addition property of equality to solve systems. So in order to eliminate one of the two variables in a system, one pair of variable terms in the two equations must have coefficients that are opposites. So when we say opposites, this just means some positive value and its negative value, or a negative value and its positive value. So 2 and -2, +3, -3, things of those matters. So our steps for solving a linear system by elimination, we have step 1, we want to write both equations in the form of ax plus by is equal to c. So we want to make sure that both equations are in standard form. Then we want to transform the equations as needed so that the coefficients of one pair of variable terms are opposites. Multiply one or both equations by appropriate numbers so that the sum of the coefficients of either the x or y terms is 0. So this just means that if we somehow don't have opposites of any of our variables, we can multiply some value to an equation to create opposites in that case. So step 3, we want to add the new equations to eliminate a variable. The sum should be an equation with just one variable now. Step 4, we solve the equation from step 3 for the remaining variable. Step 5, we want to find the other value, so we substitute the result from step 4 into either of the original equations and solve for the other variable. And then step 6, we want to check the values in both of the original equations, then write the solution set as a set containing an ordered pair. So, taking this into consideration, it doesn't matter which variable we eliminate first, but usually the most convenient option is chosen first. So this is going to be whatever feels most obvious to you when you are solving these sorts of systems of equations with elimination. It doesn't matter which variable you choose first, but the easiest is always easiest. So the system, once again, is not solved until both variables are found. So we need to have a value for x and y so we can state our final answer. Just finding one variable is not enough. So skipping on to objective 2, where we want to multiply when using the elimination method. So oftentimes we'll need to multiply each side of one or both equations in a system by some number so we can eliminate a variable. This is already detailed in step 2, but now we're going to work with a problem where we'll need to do this. So equation 1, we just want to solve the system. We want to use elimination. We see that our equations are 3x minus 2y is equal to 10 and x plus 5y is equal to -8. So remember, step 1 was just that we needed to write them both in standard form, which we don't need to do since they already are. So both equations are already in standard form. So step 1 is complete. Step 2 now is that we want to set up our equations so that the coefficients are opposites. So this is the part where now we're probably going to need to multiply one of our equations to create opposites. In our equations here, we have 3x minus 2y is equal to 10 and x plus 5y is equal to negative 8. So what we're really seeing here is that our coefficients in front of y are negative 2 and 5. This would mean that in order to have opposites, we would need to multiply some value to both equations. So for example, we would need to multiply equation 1 by 5, and we would need to multiply equation 2 by 2. So we're multiplying twice. It's not ideal. We want to just multiply once. But we see that in our first equation we have 3x, and our second equation we just have x. So we can make it easy on ourselves by just multiplying by negative 3 to equation 2, because then that would create opposites for the variable x, or opposite coefficients. So step 2, now what we're going to do, we're going to multiply equation 2 by negative 3 to have opposite coefficients of x. So we multiply equation 2, which is x plus 5y is equal to negative 8, multiplying by negative 3. And this is going to give us negative 3x plus negative 15y is equal to 24. So this is our new equation, and we can call this equation 3. And now we're going to be comparing equation 1 and equation 3. So we've transformed our second equation, and now we need to add them for step 3. We'll be adding equations 1 and 3. So equation 1 was our 3x minus 2y is equal to 10. Oh, 10. And our second equation, or third equation, sorry, equation 3, is negative 3x plus negative 15 is equal to 24. And we are adding these equations to each other. So 3 plus negative 3x is obviously going to give us 0x, which is what we wanted. We wanted to cancel out x. But now we have negative 2y plus negative 15y. And this is going to give us negative 17y. And 10 plus 24 is equal to 34. So when we want to add these equations, we want to add vertically. We want to stack one on top of the other and then add this way. So now we have 0x, which is just 0, plus negative 17y. So we have negative 17y is equal to 34, and we can divide each side by 34. Sorry, divide each side by negative 17. And this is going to give us that y is equal to negative 2. So we've solved for y. Now we want to go back and solve for x. So step 3 and step 4, I realize, are combined, because step 3, you want to add those equations, and then step 4, you want to actually solve. So when we had step 3, this is also step 4. So now with step 5, we want to solve for x. And if we want to solve for x, we can choose whichever equation we would like to solve for. So let's go ahead and solve for x in, let's say, equation 1, as this is one of our original equations. So if we solve for x in equation 1, which was 3x minus 2 times y, where y is -2, is equal to 10. So simplifying this, -2 times -2 is going to give us a +4. To simplify for x, we want to subtract 4 from both sides, which gives us 10 minus 4. So we have 3x is equal to 10 minus 4, which is 6. So we divide each side by 3 to get that x is equal to 2. So we've solved for y and we've solved for x. So now we have an idea of what our solution is in our ordered pair. It's going to be 2, -2. But step 6, we just want to check. So we want to check to see if 2, -2 is a solution of our original system. Now we have this word again, original. Our original system will be equations 1 and 2. Where we saw equations 1 and 2 are 3x minus 2y is equal to 7, and x plus 5y is equal to -8. So we can go ahead and paste these in. These were our original system. So let's actually scoot them over a little bit. So when we plug in our ordered pair 2, -2 into our first equation, we get 3 times 2 minus 2 times -2, which we said was equal to 10, where 3 times 2 is 6, and -2 times -2 is 4. So we do get that 10 is equal to 10. Then for our second equation, which we're going to go ahead and draw over here, we had x plus 5y is equal to -8, where x is +2 and y is -2. So we have 2 plus 5 times -2. 5 times -2 is -10. So we have 2 plus -10 is going to be equal to -8. So our final answer, which is our solution set, is going to be our ordered pair in curly braces. So we have 2, -2 inside our curly braces. And that would be our final answer there. Now, if we did not have to multiply one of these equations, and let's say our equations were already set up so that they already had opposite coefficients for a variable, then it would definitely be much easier. We wouldn't have the extra step of multiplying one of our equations, but we do see that multiplying one of our equations by a value, one or both of an equations sometimes, is most common. So important to go over ones like those. All right, moving on to objective 3. We want to use an alternate method to find the second value in a solution. So sometimes you'll find it easier to find the value of the second variable in a solution by using the elimination method twice. So with our second example here, we're going to solve the system being 4x is equal to 9 minus 3y, and 5x minus 2y is equal to 8. So step 1, we want to go ahead and make sure that both of our equations are in standard form, which we see equation 1 is not in standard form. So we need to make equation 1 into standard form. So we're given 4x is equal to 9 minus 3y. To make it into standard form, we're just going to go ahead and add 3y to both sides. This will cancel out our negative 3y on our right-hand side, and it will leave us with our standard form of 4x plus 3y is equal to 9. So we're going to say that this is our new equation 1. All we did was rewrite it, so there's no need to give it a new equation name. So now our system that we're working with looks like 4x plus 3y is equal to 9, and 5x minus 2y is equal to 8. This is our new system of equations. And now step 2, we want to make sure that the coefficients of one of our variables is going to be opposites. So if we look at our coefficients for x, we have 4 and 5. Our coefficients for y are positive 3 and negative 2. So with our coefficients of 4 and 5, their least common multiple is going to be 20. So this means that one of our equations is going to have to be multiplied by, let's say, negative 5 for equation 1 and 4 to equation 2. Not bad, but the numbers are a little bit on the larger side. So let's go to our y variable. So in equation 1, we have positive 3. In equation 2, we have negative 2. So we don't have to worry about multiplying one by a negative number, and the least common multiple is going to end up being 6. So this means that we would have to multiply equation 1 by 2 and equation 2 by 3, which is easier and nicer than multiplying by a negative 4 or 5. So let's go ahead and do that. So we're going to multiply equation 1 by 2 and equation 2 by 3 to gain opposite coefficients of y. So equation 1, we're multiplying by 2. So we're going to have 4x plus 3y is equal to 9. We're multiplying each side by 2. And this is going to give us 8x plus 6y is equal to 18. And we're now going to call this equation 3. Then we're multiplying equation 2 by 3. So we have 5x minus 2y is equal to 8. We're multiplying each side by 3. And now we're going to get 15x minus 6y is equal to 24, which is now going to be equation 4. So this means that our new system of equations 3 and 4 are 8x plus 6y is equal to 18, and 15x minus 6y is equal to 24. So we see we have opposite coefficients for y. And now step 3, we want to add our equations. So we're going to add equations 3 and 4. And remember, when we add them, we want to add them vertically. So we have 8x plus 6y equal to 18 plus 15x minus 6y is equal to 24. Adding these values together, 8 plus 15 is going to give us 23x. 6 plus negative 6y plus negative 6y is going to give us 0y. And 18 plus 24 is going to end up giving us yeah, 18 plus 24 is going to go ahead and give us 42. So simplifying, which is step 4, we're going to have 23x plus 0y, which is just plus 0, is equal to 42. Where now we want to divide by 23. And we're going to get that x is equal to 42. Sorry, x is equal to 42 divided by 23. And now if we want to find the value of y, and we're going to go ahead and plug in x, it's going to be really annoying to go ahead and try and find y by plugging in x, because x is, quite frankly, an ugly fraction. It's going to be difficult for us. So what we can do instead is use our elimination method again. So now we know what x is, so we're going to go back and we're going to try and solve for y. So since finding y by plugging in x will be messy and difficult, we can just use the elimination method again. So what we're going to do is we're going to end up going back to our step 2. So we'll need to repeat steps 2 through 4 to solve for y now. So going back to our step 2, where we had our equations 4x plus 3y is equal to 9 and 5x minus 2y is equal to 8. We're saying now step 2, you'll say part 2, and we're using these original equations. So now we solve for y. So these were our equations. And if we want to now solve solving for x. We solved for y last time. So now we want to solve for x. Well, technically just finding the coefficients that are going to work out. So we're canceling out x. So we technically are still solving for y, but we're canceling x. So if we want to cancel out x, let's multiply equation 1 by -5 and equation 2 by 4. And this is going to give us opposite coefficients for x. So 4x plus 3y equal to 9. Multiply each one by -5. It's going to give us -20 plus -15y is equal to -45.